In this video, what I'm going to do is programming challenge number 1. It's actually called the sum of numbers, and I've copied and pasted the instructions in here. So let me read that out to you. Write a program that asks the user for a positive value. The program should use a loop to get the sum of all the integers 1 up from the number entered. For example, if the user enters 50, the loop is going to find the sum of 1, 2, 3, 4. So let me give you a hint. When you do something like this, you always want to start out with easy data to check. So you'll see what I'm talking about in a minute. So what you want to do when you get a program, the first thing you want to do is look to see what input variables do we need. And do we need any constants or anything like that? So right now, it looks like we need two variables, a number and something to keep track of the sum. So you can always add that. That's why I always recommend doing an IPO, the input, processing, and output, and just jot it down, and then you can add things instead of just starting the code. So we're going to make them integers. So we have integer here, and I'll just call it number. And remember to initialize it to 0. And we'll call sum. And we'll initialize that to 0. So now what we need to do is ask the user, what number do you want to stop at? So if we say 5, we're going to get the sum of 1, 2, 3, 4, and 5, starting with 1. Now, one thing to understand is a positive number is actually defined as something that is greater than 0. And a negative number is something that's less than 0. 0 is actually neither positive or negative. So right off the bat, we would want 1. And it wouldn't make sense that you want to add up to 0 because it wouldn't do anything. So first thing we're going to do is ask the user, let's just say, how high would you like to go? Now notice I am putting a question mark here and a space. And I am not putting an end line. Remember that in the back of your head. I am not putting an end line. We'll talk more about that in a bit. So then what we're doing here is we're getting a number. So now we have a problem. The problem is, what happens if I run this and the user puts in -5? So what we need to do in this program, we need to have a way to force the user to put in a positive number. You don't want to end the program every time they do a positive number. My favorite way of doing that is with a do loop. So I'm going to start off with a simple do and a while. And then we need to fill in the blanks. And the do while loop has to have a while, it has to have a condition, and it needs to have a semicolon at the end. So we don't need that here. So we're going to put that right inside the loop. So now basically it's going to keep doing this forever and ever because we don't have an exit condition. So we'll start off simple and then we'll make it a little bit more clear. So let's start off with our condition is we're going to keep doing this as long as number, we can either do not greater than, it's easier to me just do less than 1. So at this point in time, let's just go and do it. We'll run it. We're going to do one thing. We're going to check it. So I'm going to put in a couple numbers and see if it continues to go back in and ask the user. So it says, how high would you like to go? Let's put in 0 and see what happens. Okay, it's asking me again. So let's put in -5. It says it's asking me again. Now the user has no idea at this point in time why he's getting that. So let's put in 1 and see what happens. And that works out good. So to make it a little bit more clear, I'm going to add a Boolean. Now that's not a requirement of the program, but it makes your program more readable. Remember, I always talk about when you look at your code, you want to make it where you're looking at it and it's very easy to find out. If you did everything properly, it's easier to find out if you did not, where you went wrong. So we're going to create a Boolean and we'll just call it need data. And we'll say true because obviously we need data. So now we need to set the condition for what means we still need data. So we're going to set need data. Now again, this is not part of the program to have the Boolean, but it really makes your program so much easier. Plus, it gives you the opportunity to give an error message to the user. So let's go and start off without using the Boolean, and you'll see what I'm talking about. If number is less than 1, so we're repeating code here, but then we're going to fix it. So number, then put C out. You must enter a positive number. And we can do on the next line or this line as well. Doesn't matter. C out. Please re-enter. And we'll do end line again. So now the dilemma with this here is it's not any more readable than it was before, but we're also calculating and checking to see if number is less than 1 twice. So we can avoid that by going Boolean, the need data. Our condition is we need the data until the user puts something that's 1 or greater. So we're going to do need data equals, and it's nothing more than testing a condition. Number is less than 1. So now if we type in 5, this means need data is false. So let's get rid of this here and put in need data. So what we're saying now, and we'll change this to as well, we're saying here if we need the data, then we give the user a message. If we don't need the data, then. So this is basically saying if need data equals false. This line here basically says if number is less than 1, need data equals true, else need data equals false. That's the way the Booleans work. And so we have this here. And so now now you won't be able to hear this, but I'll put in an alert. And what'll happen is it'll beep, it'll tell the user, you must enter a positive number. So now we're going to test it. We'll test it with 0, we'll test it at 1, and then we'll test it with something that is greater than 1. So let's go here. And how high would you like to go? Let's go 0. And it says you must enter a positive number. Please re-enter. Then we'll do -5. The same thing, and then we'll do 5. So now everything is good. So now we have valid data. So now this is a loop here. It's just a simple do while. Do while loops are great for data validation. You can also use a while loop. The thing I don't like about a while loop, it means you have to repeat this on the top. C out, hi, how would you like to go? C in number, put it up here, then do while, and you have to check the need data first. So it's a little bit more difficult to do to accomplish the same thing. So now we're going to use, let's see what it says. I think it says to do a for loop. So let's do a while loop, and then we'll do the same thing with a for loop. So once we have the number, we're going to do while and we need a counter now. So we can't do while number is less than 10, although we actually can, but it depends upon how clear you want to make it. So let's just do this. The issue is we need to start with 1. So we need to have a counter, or we need to have a starting number, however way you want to call it. So let's type, let's call it counter equals 0. Now, if we do it with a for loop, you don't need the counter. So I would do this in a for loop, but let's do it in both. So we have while need data. So now we're going to do the same thing. While counter is less than or equal to number. Now we have a problem because counter's 0. So we're going to fix that in a minute. So we're going to initialize counter to 1, just outside the loop. So you're going to say, why didn't you just initialize it to 1 up top here? And you could very well have done that. The issue with that is what happens if you forget to do it or you want to change it. It's always better, or you use it a second time. It's always better to set it just before. That way you know it's going to start at 1. You can't have any issues. So let's just do right now, let's print out counter. We just do cout counter, and we won't do anything else to see if our loop actually works. So if I did this right, if I type in 5, it should print out 1, 2, 3, 4, 5. Now, there's one dilemma. With this while loop here, we have to manually increment counter. So what we need to do here is type in counter plus plus. If you do not manually increment counter, it's going to always print out 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So let's go in and let's start out with 5 and see how that works. Do 5, and it goes 1, 2, 3, 4, 5. So that looks good. So that part works. So now what we need to do is we need to now do the sum. Now the one thing you don't want to do here is initialize the sum or the counter into 1. You want to do it right outside the loop. And we started out with 0. So what we're going to do here now, every single time we initialize number and we go through the loop one more time, we're going to update sum. So what we're doing here is we're doing sum plus equals counter. So the first time around it should be 1. The second time around it should be 3. And let's put in comments that this is the same thing as sum equals sum plus counter, or add counter to sum. So now what we'll do here is we'll do counter, and then we'll keep a running tab of sum. So we want to have a little bit of space here. It's not going to be much space, but we'll have a little bit of space. Then we'll do sum. So when we type in 5, we should get 15. So let's see what happens. So 1, 3, 6, 10, and 15. So we know that that works. So what we're going to do here, let's try it with a different ending number. And we'll do, let's try 10 this time. So 10 should be a lot more. So let's do 10. And that looks good. So you can see 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15, and so on. So that's good. And we'll do this later on. We'll format it and make it look nice. So let's go and do the same thing, only we'll use a for loop. So this is the advantage of a for loop. We don't need another variable called counter. So if you recall correctly, a for loop allows you to initialize a variable and declare a variable right inside a for. You don't have to declare it up top here. I know that some people have lost some points because they would do some work here and then later on declare something. This is in a for loop. This is the best way to do it. So we want to declare it as an integer. And a for loop can have, it's okay to have a single variable. But if you're not thrilled about it, you can call it something different. But usually for loops contain either I or J. That's just normally the way it is. So what we want to do is we want to start it at 1. So we're saying, okay, let's start the loop at 1. Then how are we going to end the loop? Well, the loop is going to end when I is greater than number. So what we need to do it in order to keep going through the loop, we need to be less than or equal to number. And then we need to increment I. And we can actually copy this code. We just need to change counter to I. Now, we could actually use counter here, and this counter would not be the same as the counter we declare. When we get done with this, I'm going to show you what I'm talking about. So we're going to do, this is I and I. And we do not have to do this because we're incrementing I here. So let's go and see how this works out. We'll do 5 and 5 to start off with. And I always say, make one change and then test it. So we have 5. So we have 1, 2, 3, 4, 5. And then, okay, now look at this. This doesn't make sense. How is it possible that we get 15 one time and 30? Remember I talked about the importance of always initializing things just before a loop? There's the reason why. So we're going to copy this here. And we're going to copy it here. And let's just add one extra endl when we get done to separate it. And let's go and run it again with 5. So we have 1, 3, 6, 10, and 15. 1, 3, 6, 10, and 15. Now let's try it with 6, which is just one more. So this time it should be 21. And it is. So that's just how it goes. So I'm going to end this video now. Or actually put it on pause. Then we're going to do a little bit of cosmetic stuff to make it look a little bit nicer. So what we're going to do now is one final thing is we're going to make it a little bit nicer. So we're going to do it on one, but we're not going to do it on the other. And when I format stuff, oops, not IOStream, we went IOmanip. So what we need to do now is we'll leave this here, and this one we're going to do. So we're going to start off with set C out fix. Now we only have to do that one time. And what we're going to do is we're going to set the fill character to a 0, but first let's set the width. Remember, one thing is whenever you set the width, you have to set it every single time. So let's go and set the width for 3. And you'll see what that does. But then we still have a dilemma. So we just do it with 5. And so well, that doesn't really help us any. So why don't we let's do a set fill. And what we'll do here is we'll put leading zeros here and see how that looks. And I'm going to actually change this to 2. And we're going to do a set fill. So if you're not sure whether you need to set fill every single one, then all you need to do is try it right up top here. And we're going to use a 0. If it doesn't work on all of them, then you know you need to move it in here. But the set width will be required on every single one. So let's go here. And let's see what this looks like. We'll do 5. And now we have 0, 1, 0, 1, 0. So if we do the set width to 3, say, okay, because we want a little bit of space here. This is what's going to wind up happening. So let's set the width to 3. And that's of no value. We want the space here. So what you need to do here, even though it can be kind of a time consuming, we need to now I'm going to do this wrong first. So these are ways that you can fix something if it doesn't work out right. So let's put a space before the I. And let's see how that works. It seems like that would work, but will it? Let's see. That doesn't make sense to me. So that's an issue. So what we need to do here now is we just need to move this space here, and let's see how that works. So we're putting a space before the I, and we're setting the fill to 0. So let's see how that works. We'll do 5, and that looks nice. So that looks good. And you can always play with cosmetic stuff, whatever you want. You could do something like this till you get it exactly the way you want it, putting a parentheses. There's other ways to format it. So that looks a little bit nicer. Now we could do the same thing with this over here. So let's make this set width, and let's just make it 4. And let's see how that looks. So now we have the set fill 0. We don't want that. So now we can't do that anymore. So the way you fix that is we need to get rid of this set fill here. And we need to put it here. and we have extra, and then we can go back here to set fill, to just a plain space. And let's test that. So notice again, I'm constantly doing one thing and doing the other. And let's put this stuff on a separate line so it's a little bit easier to read instead of one just long line. That is acceptable to do. And we'll try it one more time and see if that makes it look nice. So there we go. So now all this lines up nice and keen here. So if we had 100, it would be, let's do it where it's going to be over 100 and see how that looks. You want to keep testing stuff. So let's do 20. So now that still lines up nice in there. So now we're looking good. So that is this for this video. We've done here is we've done the same thing twice. We've formatted one and left the other. We looked what happened if we didn't initialize some just before the loop. And we saw how to make it look somewhat nice, somewhat pleasing.